This question says, using the 4n plus 2 pi electron rule, also called Huckel's rule of aromaticity, label the structure shown below, this one here, as aromatic, non-aromatic, or anti-aromatic. In order to do that, we follow three rules. Number one, is the structure cyclic? Number two, do you have continuous conjugation? Number three, does it satisfy the 4n plus 2 pi electrons? Then that will be aromatic. Or 3b, 4n pi electrons, that will be anti-aromatic. Now the first rule, is this structure cyclic? Yes, if you look at it, that's a cyclic system. So that's a ring, and therefore that first rule is satisfied. Number two, do you have a continuous conjugation? That means you have continuous p orbital. If you look at this, this is a pi bond, meaning that you have p here and p orbitals, and then that's another pi bond, meaning that has a p orbital. That also is a pi bond, therefore it has a p orbital. This oxygen has two electron pairs. Each of those pairs is on a p orbital. Remember, we have px, py, and pz, which are all perpendicular. So one of the p's will have one pair, and then the other p will have the other pair. And because of that, only one of the p's will overlap. So we only count two of those electrons, not all the four. Here you have a positive charge, which is also on a p orbital. And because of that, you have continuous p. So that rule number two is satisfied. And now we go to rule number three, 4n plus 2 pi electrons. If n is 0, then 4n, that's 4 times 0, gives you 0 plus 2, and therefore that will give you 2 electrons. If n is 1, 1 times 4 is 4 plus 2, will give you 6 electrons. If n is 2, that will give you 10 electrons. And then if n is 3, that will give you 14 electrons. So basically we're looking at to see if we have 2 electrons, 6, 10, or 14, and that will satisfy the 4n plus 2. Now the last part is 4n pi electrons. If n is 0, then that gives you 0 electrons. If n is 1, it gives you 4 electrons. If n is 2, it gives you 8 electrons. If n is 3, it will give you 12 electrons. So basically we're looking at 0, 4, 8, or 12 electrons. Now going back to the structure, you'll see that this pi bond has 2 electrons. Anytime you see a double bond, it means 2 electrons, but that one is outside the ring, and therefore you don't count that. Same thing here, you have a pi bond, and that's 2 electrons outside the ring. Now we're left with this one here, that's pi bond, and therefore that's 2 electrons in the ring. So you count that. So that's 2 plus, next, that's 0 electrons because it's a positive charge. And then here, for oxygen, we only count one of the pairs. Remember, we only count one of the p's because they're perpendicular. So 2 plus 2 gives you 4 pi electrons. And you'll see that that satisfies this one here, and therefore it is anti-aromatic. So this structure is anti-aromatic.